So when we calibrate, we sometimes adjust, and if we do adjust, we verify before we maybe have to recalibrate. And calibrations and adjustments, they have a limited lifetime, and that is what this wheel tried to show, that you have to go over again. You have to have this as an everlasting cycle. A measurement instrument may drift, which means that the shown value may change for a given object. So after time, wear and aging, for example, may result in this. Also, rough treatment, overload, that you use it at the end of the range always. Maybe it's meant to measure certain pressure, and you double that value. Well, that might cause the instrument to drift. Corrosion or other effects caused by the atmosphere. Memory effects. Maybe it's charged with magnetism, and that will cause the instrument data to change. Calibrations gives the status of the instrument and the exact moment of the calibration. So that those are two things that are given from the calibration: the status of the instrument and the moment, but nothing about what the future might bring. So such a calibration should be performed on a regular basis. Therefore, when you have a certified calibration of an instrument, it will come with a date stamp. So you have to recalibrate within a given date. The calibration history, the result from a former calibrations must be archived to gain as much knowledge as possible about the instrument. So you have to keep a track record of the calibrations that have been performed. So if you have an instrument and the changes are very small from year to year, you see that the changes are barely non-existent, well, then you can increase the intervals between calibrations. And if the change is linear, that is predictable, the change in the measured values, well, then you can do something called, you can extrapolate before the next calibration. You can assume, let's say, value A, B, C, and D, and you didn't measure number C, you just assumed what it would be because of the track history. Be careful when adjusting instruments. Going back to this point again, calibrate, do that often. Adjust, well, it's not always performed because you should really be careful. You might lose your calibration history if you adjust. It's often recommended that you instead modify the instrument characteristic equation, so the calculations based on your measurement is adjusted. That would be a better idea. For example, if you have a spring scale, and you adjust and you have an adjustment screw there, you might actually change the attributes of the instrument over time. So instead of using the screw, well, then you should maybe just be aware of what numbers you have to multiply your results with in order to get the correct result. Standards, we have here a standard called NSEN ISO 10012 2003. Well, what does this stand for? The ISO is the International Standards Organization, so that's an international standard. The Europeans have adopted the international standard, and the Norwegians have adopted the European again. So what this means is that you have a Norwegian standard that follows the European, that also follows the international standard. So it's a good solid standard history associated with this. And it's from the year 2003. These standards tells us about measurement management systems, requirements for measurement processes and measuring equipment. So this is what we have to follow when we adjust and calibrate our instruments. It specifies the generic requirements and provides guidance for the management of measurement processes and also metrological confirmation of measuring equipment. So this is the standard to follow in order to know how often to calibrate, how to calibrate, who should perform your calibration, etc. This is a document stating all the requirements there. Finally, statical properties of measurement systems. There are 4 R's that we should consider. The reliability. That's the overall consistency of a measurement. Repeatability. How the same item, under the same conditions and in a short period of time, produces the same results. So this is also found in the precision, really. Reproducibility, the ability of an entire measurement to be duplicated by the same setup or another setup. So if I produce some results with my measurement instrument, that measurement has good reproducibility if I can do it again at some other plant, maybe with other instruments, but I can confirm my measurements with your instruments maybe. And then you have replaceability. That is the capability of one component to be replaced by another component within a single system, and the system as a whole should produce the same results. So if I have a system, a plant for example, producing diesel or whatever, and I have to replace one element there, for example a pressure meter, the system as a whole should work in according to the same standards if I have a good replaceability on my instrument. So those are 4 R's that you will hear often if you work with reliability and measurement systems, but don't mix up the 4. Learn the difference between them.